Hello and welcome to our last lesson for Standard 2. We're going to finish off looking at the normal distribution. Specifically today we're going to look at further applications of the normal distribution. So this is still finding ourselves a z-score, but using it in a slightly different way. So remember our 68, 95, 99.7 rule? So 68% of all of the scores are going to fall between 1 and -1 standard deviations from our mean, which is at 0. Then 95% are going to be between 2 and -2. And then the full 99.7%, so almost complete, will be between 3 and -3 standard deviations. Now that's a slightly different normal distribution curve that you've got there. What each of those numbers represent is what is in that section. So for example, between 0 and 1 standard deviation, we've got 34%. Well, how can we work that out? Well, that's half of 68%. Right? Between -1 and 1 are going to be 68%, so that's 34 and 34. Then between 2 and -2, we're going to have 95%. So 95%, we're going to take away 68% from that. And then what we've got left over, we divide that by 2, and that's going to give us 13.5%. So between 1 and 2 standard deviations is 13.5%, and between -1 and -2 is also 13.5%. Now on your reference sheet that you get with the HSC, you will have a normal distribution curve marked on there with no numbers, but you will be told that the 68, 95, and 99.7% rule. You will be told that. My advice then is to divide up those numbers and write them on your normal distribution curve that's given to you the way that you see that one there. Right? That will actually help you out. Now remember, it is symmetrical, so everything from 0 down will be half, so 50%, and then everything above 0 will also be 50%. All right? It is nicely symmetrical, and that will come in handy. So let's look at some examples. So example 1, the height of a class of children are normally distributed. The mean is 145 centimeters and the standard deviation is going to be 6 centimeters. We want to know what percentage of children in this class lie between 139 centimeters and 163 centimeters in height. So if we want to work out those percentages, what we are going to need to do is standardize those scores. So in other words, find out the z-scores. So we're going to need to do both, 139 and 163. So first let's do 139 centimeters. So remember that our standardized score is just our raw score minus the mean divided by our standard deviation. So that means we've got 139 less our mean of 145, all divided by our standard deviation of 6. And we get our first z-score is -1. So that's for all 139. We want to repeat that process now for 163. So again, raw score minus the mean over our standard deviation. So it's 163 minus 145 all over 6. And that works out at being 3. So we want to know now, when we say the percentage between 139 and 163 centimeters, it's the percentage between -1 standard deviation and +3 standard deviations. So if we bring up our normal distribution curve from before, we want all of the percentages between -1 and +3. So if I shade that area in there, that's everything from -1 up to +3. So what percentage is that? Well, I'm just going to add those numbers together. So we've got two lots of 34, a 13.5 and a 2.35. Adding those together, we get 83.85%. Right, so that shaded area is 83.85% of all of our scores. So because this is normally distributed, the heights of these children, we can now say that what percentage of students are between 139 and 163 centimeters? Well, it's a roughly 84%. Of the children in this class are going to be between 139 centimeters and 163. So example 2, now we've got 700 jars of jam, and the mass of those jars are going to be normally distributed. So the mean weight or mass of all of the jars is 420 grams, and the standard deviation is going to be 3 grams. And we want to know what percentage of the jars are more than 426 grams. All right, so again, we want to find ourselves a standardized score. So we're taking our raw score, our X of 426. We're going to take away our mean mu of 420, and we're going to divide it by our standard deviation sigma of 3. So in a calculator, that comes back as a z-score of 2. So that means we are looking at 2 standard deviations. We want to know how many are more than 426 grams. So we want to know how many are more than 2 standard deviations. So what we've got then is, well, what's our probability that our z-score is greater than 2? So what's greater than 2? Well, it's our 2.35 plus our 0.15. All right, remember that we've got 99.7 between 3 and negative 3. So that means we've got a total of 0.3 outside of those numbers. So half of that 0.15 will be less than negative 3, and half of that 0.15 will be greater than positive 3. So then the probability that my z-score is going to be greater than 2, well, that's going to be 2.5%. So then what percentage of the jars are more than 426 grams? Well, it's 2.5%. All right, we found ourselves a z-score. We need to make sure that we read the question carefully, because here it says more than 426 grams. All right, common mistake is people work out 2 standard deviations and then add up everything less than 2 standard deviations. All right, if the question says more, we got to look to the right of that number. If it's less, then we look to the left. So let's look at one where it says, what's the percentage of jars less than 423 grams? All right, so first step, same as always, standardize our score. So it's our X minus mu over sigma. So our X is 423, our mu, our mean is 420, standard deviation is going to be 3. And the calculator tells me that that gives me a z-score of 1. So we want to know what percentage of the jars are less than 1. So it's going to be 0.15 plus 2.35 plus 13.5 plus 34 plus another 34. The easier way, and there's nothing wrong with doing it that way, but there is an easier way, everything less than 0 is 50%, right? That whole half there is exactly a half. So then if I just want everything less than 1 standard deviation, well, it's everything less than 0, which is a half, 50%, plus 34%, the percentage between 0 and plus 1. Right, so the probability that z is less than 1 is going to be the first half, 50%, plus 34% from 0 to 1 standard deviation, which is 84%. Therefore, 84% of the jars have a mass that is less than 423 grams. This sort of thing is used quite often when you look at any sort of manufacturing. If you look at, like, for example, boxes of cereal, and they'll say it's like 600 grams net. All right, so that's what they've done, is they've weighed out a certain amount, and then they've worked out, well, what's the percentage that these boxes are actually going to be of that amount of weight, and it's not 100%. So that's why they put the net on the boxes, is so that they cover themselves to say that on average, mathematically, we've worked out that there should be 600 grams, for example. And that brings us to the end. So exercise 9F on page 369. If you have any questions, as always, shoot me an email or questions on Google Classroom. But otherwise, that's it. Year 12 done. Next term, though, we will be doing revision sessions, so basically like tutorials or seminars, whatever you want to call them, where I'll be going over each of the topics that make up the course. I'm sure you're well aware that it's voluntary attendance next term, so feel free to come along if you need help with anything. I will have a timetable published hopefully by the end of this week. That'll be up on Google Classroom, so you know exactly what days I will be covering what topics. But yes, if you've got any problems, let me know. Otherwise, I will see you next term. Have a good holidays. Enjoy your 2 weeks. Take it easy. Don't stress. Life is more than the HSC. All right, I've got all the confidence in the world that you guys will do well. Don't stress, don't panic. So have a good 2 weeks holidays, and I will see you next term.